Hi everyone. Last time I discussed the normal distribution. I introduced normal distribution, and we said that the normal distribution is one of the most important distributions in statistics. Today I want to go ahead and talk more about the normal distribution. But before I do that, let me remind you about what we discussed last time. We said that the normal distribution, let me turn the orientation of my page. We said the normal distribution probability density function f of x is given by f of x is 1 out of sigma times the square root of 2 pi, then the exponent x minus mu squared, okay, divided by 2 sigma squared. This function is defined for, okay, minus infinity less x less infinity. Now, this is a complicated function to memorize. Do not attempt it to. If you want, it is okay, but it will always be given to you if necessary. At this stage, we don't really integrate this function because it is hard. You know, when we're finding probabilities, we go ahead and integrate the function. If I try to remind you what we did in continuous random variables, we're integrating the probability density function to get probabilities. But in this case, integrating this function will really be very complicated. So tables are used. Now, if x follows a normal distribution with mean mu and the variance sigma squared, then we write, okay, if x follows a normal distribution with mean mu and the variance sigma squared, we write x follows a normal with mean mu and then variance sigma squared. So we need two parameters to define the normal distribution. We need the variance and we also need the mean. Okay, that's just a notation. Let me remind you real quick of the properties of the normal distribution. We say that in the normal distribution, the mean, the median, and the mode are equal. So that's one of the most important properties of the normal distribution. Mean equals to mode equals to median. Then we say the total area under the curve should be equal to 1. In all random variables, continuous, you remember, and discrete, the total area under the curve was always 1. It is the same thing with the normal distribution. Also, the normally distributed curve should be symmetric about the mean. So the mean is at the center. At the center, we have the mean. So this is the center, and we have the mean at the center. There should be exactly half of the values at the left of the curve and exactly half of the values at the right of the curve. So since the mean is at the center, the values on the left and the values on the right of the mean should balance. So if you have a value right here, there will be a corresponding value on this other side. If you have another value, then there will be another value this side. If you have another third value, there will be a corresponding value on this side. So the values to the left and the right of the mean must always be the same. And the normal distribution should be defined by the mean and the standard deviation. So we say that if x follows a normal distribution, when you write x follows a normal with mean mu and then variance sigma squared. But the variance is the square of the standard deviation, or the standard deviation is the positive square root of the variance. So when we are talking about the normal distribution, two parameters should be talked about. That's the mean and the standard deviation. So these are some of the properties I wanted to remind you. Okay, I discussed this last time, but that video was cropped badly, so I have made an effort to go through what I talked about last time in this video. How do we find probabilities? The probability that x lies between A and B is written. Okay, this is how we write the probability between two x values. Probability of x is more than A but less than B. Now, to find the probability, we need to find the area under the curve between A and B. So one of the ways of finding area under the curve is by integration. But the normal distribution function is very hard to integrate. So what we do to find the areas between two x values, we go ahead and use tables. Okay, there is a special table designed for this purpose. Since we are going to deal with the different normal distribution functions with different means and variances, what we are going to do is we have to come up with a uniform table. And that uniform table is what we call the standard normal variable, Z. So let's talk about the standard normal variable, Z. So why do we need the standard normal variable, Z? In order to use the same set of tables for all possible values of mu and sigma squared, the variable x is standardized so that the mean is 0 and the standard deviation is 1. So we need to standardize all normal distributions so that the mean is 0 and the variance is 1. Okay, I'll give you this information. Is 1. Okay, so it is all about standardizing the mean of any normal variable x so that the mean is 0 and the standard deviation is 1. Okay, and you know that variance is equal to standard deviation squared, because sigma here is standard deviation. Okay, so the square of the standard deviation is the variance. This is standard deviation. So we come up with a new normal variable, and this standard normal variable is what we call Z. Okay, so let's have this standardized normal variable is called Z. Let me give you this information. And this new normal variable, which is the standard, follows a normal with mean 0 and then variance 1. Okay, so we're going to discuss the standard normal variable Z and how to find the probabilities given Z values. So to standardize x, where x follows the normal with the mean mu and the variance sigma squared. Okay, this is what we do. We subtract the mean mu, and then we divide by the standard deviation sigma. Okay, so divide by the standard deviation sigma. So when you subtract mu and divide by the standard deviation sigma, then you obtain the standard variable, the standard variable z, which will be x minus mu divided by sigma. Okay, and here we are saying that z is the standard normal value, which follows a normal with mean 0 and then variance 1. So that's how we standardize any normal variable x to the standard normal z. Okay, subtracting mu, which is the mean from the x value, and then divide by the standard deviation. So next is using the standard normal tables. How do we use the standard normal tables? Okay, so we want to talk about how to use the standard normal, okay, variable z, standard d, using the standard normal tables. Well, we say that because the normal function is very hard to integrate, we use tables. So they are tables, they are standard tables that will give you the probabilities for the standard normal variable z. So the question is, how do we use these standard normal tables? So the standard normal tables this give the area under the curve as far as, okay, as a particular value z. So this is written phi of z. Okay, now this is just a writing. This is how we write phi of z, and this area gives the probability that z is less than a particular value. Okay, so that the probability that z less than some value z, this probability is what we are calling phi of z. So this is what we are saying. If you have a standard, if you have a normal curve right here, okay, and then this is my curve. Okay, so somewhere here, I have the mean, and you have a particular z value right here, which is z. Then what we are calling phi of z is the probability. This is what we are calling phi of z. Okay, and this is the probability that the standard normal variable z is less than that value you're talking about. Okay, it is the, you pick one. You either use probability or you just use phi of z, but that's what we're talking about. And then the standard normal tables will always give us that probability. So I have about 3 tables I'm going to show you here. Okay, the first is reading the probabilities of values of z that are on the negative side. Then the second reads the probabilities of the values of z up to the positive side. Then the third table will be reading between 0 and z. Okay, so we have to interpret all those tables and you have to know which table you're using, okay, to standardize a normal variable x to z. Okay, here I have a table that reads for values of z that are negatives. Okay, let me show you here. Now, this table is reading z values. This is what we are calling phi of z. I think that is not going to show well. This area you are seeing here is the phi of z, and we want the probability that z values are less than, okay, that particular value of z. Let me call this z1 here. So this is phi of z1. We are looking at the probability that z is less than z1. Okay, so you look at all the z values, okay, that are less than that particular value, and this is a standard table. Okay, it's an extract of the table, so you can see clearly that if my z value, if I have z equals to 0.0, negative 0.032, okay, so this is what happens. We are looking at the negative value, which is 0.032. Or let me pick a better one, because that looks to be a bit far. So let me use this. I want to read the probability that z is a minus 2.73. So what I do, the first thing you have to do is to look for 2.7. Where is 2.7? 2.7 is right. Let me use red. Red might appear. Okay, 2.7 minus 2.7 is right here. Okay. Then you look for the second place of decimal. Okay. This is 2.70, 2.71, 2.72. Okay. And 2.73 is right here. Okay. So what I'm looking for is basically this part. I'm looking for that probability, the probability that z of phi of minus 2.73, okay, the probability is 0.0032. That's what I get from this table, okay. This is a standard table that you will get from standard textbooks. You may not have chance to find it, like the Uganda National Examination Board does not print this table. It prints a table that reads between 0 and the particular value of z on the positive side. I also explained that in just a minute. Okay, so what I'm trying to emphasize here is how to read these tables. Okay, so let's read one more value. Now let's look for the probability that z is less than minus 1.1. Okay, 2. So I go ahead and look for 1.1. Let me expand this table. Okay, 1.1 is right there, but I want 1.12. Okay, 1.12. Let me change, because people think that I'm only thinking about 2, 3, and okay. Let me say 1.16. Okay, 1.1 is right here. This is 1.1. Okay, this gives the first place of decimal. That's 1.1. So this is 1.10, 1.11, 1.12, 1.13, 1.14. So I have to move my table. Okay, 1.15, 1.16. Okay, is right there. So if I zero in, if I try to zoom this in, then you have the probability z is minus 1.16. This probability is 0.1230. Okay, so this is how we use the standard normal tables, but there is always a challenge. Sometimes you may not have chance to access this table. In most cases, you'll have chance to use the other table that reads between 0 and the positive side. So how do we go about that? Next, I have this other table. It's also a standard normal distribution table. This is reading the probability that z is less than a particular value on the positive side. So the area you see in green here, okay, this area is the probability that, let me make it big thick so you can see. This is the probability that z is less than a value. Let me call it z naught. So it's less than z naught right there. Okay. And if you don't want to write this, you can still go ahead and write this as phi of z naught. The two mean exactly the same thing. So you only choose one and go by that, as long as you understand what you're doing. Okay. So what's the probability? what's phi of 1.78? So phi of 1.78, what we do, we look for 1.7. 1.7 right here, okay? So this 1.70, 1.71, 1.72, 1.73, 1.74, 5, 6, 7, 8. So this is the probability that Z is less than 1.78 and the probability is about 0.9625. So this includes all of values on the negative side. You know, the negative side from minus infinity up to 0, that area is 0.5. Okay, so what I'm trying to say, this area right here is 0.5. Now 1.78, okay, 1.78 is a value on the positive side. So you have to add this area to the first area. Okay, that's why the answer is more than 0.5. Okay, so it is important you learn how to read these normal tables. So when we are dealing with the normal distribution, we prefer a high degree of accuracy. So we like using the decimal places instead of two decimal places. All what I've been reading here is just two decimal places. What about three decimal places? Okay, let's discuss and see how to read the probabilities for Z values that are three places of decimal. And then we shall also look at how to read probabilities of Z values that are between 0 and a particular value on the positive side. Okay, then how do you use a table that reads only from 0 to the positive side? So that's what I'm going to discuss in my next part.